Okay, we're back to the last problem for chapter 10. And it asks how much energy is required to convert 10 grams of ice at minus 5 degrees Celsius to water at 100 degrees Celsius. Okay, now once again, let's think about where we are at this curve. I started ice at minus 5 degrees, so about here somewhere, close to 0, but a little below. Minus 5 degrees, all the way to water at 100 degrees. It doesn't say anything about steam. It doesn't say anything about boiling it away. So I stop with liquid water at 100 degrees. I start with ice at minus 5, and I end up with water at 100 degrees. Once again, I won't have all of the steps here. The first part, my first step, would be to convert the mass from grams to moles, because I will go through a phase change, so I will have to use moles of water. Therefore, I can take the 10 grams of ice, so H2O, times, okay, I know 1 mole of water weighs 18 grams. My grams will cancel out, and I will have 0.56 moles of water. Now that I have this, I can use Q equals MC delta T, and this Q N times delta H F. The first part, though, I start right here at minus 5 degrees Celsius, and I end up here at 100 degrees Celsius. The first step, I'm at the slope line, so I have to use Q equals MC delta T for ice, because I am below my melting point. Q1, therefore, will be M times C for ice times delta T. The mass is 10, so 10 grams times the C for ice is 2.03 joules per gram degrees Celsius times, let's look at the delta T. My final temperature is 0, right? For this little bit here, I end up at 0 before I start the melting part. So 0 is my final temperature minus a minus 5. My degrees Celsius will cancel, my grams will cancel. This gives me 5. So that comes out to be 102 joules, 102 joules. Let's convert it to kilojoules by dividing it by 1,000. And that comes out to be 0.102 kilojoules. That's my first step. Now I have ice at 0 degrees. I go through my melting phase to get to water at 0 degrees. Because I don't have a temperature change, I have to use this formula. My Q2 then is equal to N times delta H of fusion for water. N is 0.56 moles of water times delta H of fusion is 6.01 kilojoules per mole. My moles will cancel, and if you do that, it gives you about 3.34 kilojoules. That's my second step. Now I am right here. I have water. This is still at 0 degrees. This is at 0 degrees. This is ice, and this is water. And I'm taking water from 0 degrees all the way to 100 degrees. My third step, therefore, will be, once again, I am going through the slope part of the graph, so it's going to be M times C, but in this case for water, the liquid, times delta T. the mass is 10 grams. 10 grams times C for water liquid is 4.184 joules per gram degrees Celsius times, let's calculate delta T. My final temperature is 100 because that's where I end. My initial temperature is 0. It will be 100 minus 0 degrees Celsius. That will cancel out, grams will cancel, and if you do the math here, it will be 4,184 joules. Convert this to kilojoules by dividing it by 1,000, and that gives me 4.2 approximately kilojoules. The last step then, the very last step, is adding all of the steps together. So my Q total is going to be Q1 plus Q2 plus Q3. And if you do all that, you get about 7.64 kilojoules. That's the total amount of energy that is needed to take ice from -5 degrees and convert it to liquid all the way to 100 degrees Celsius. You can see that for these last two problems, we didn't have to do all of the steps because we stopped. We didn't take it all the way to steam here. We just stopped right before it started to evaporate. We had liquid at 100 degrees. I could have said steam. If I said steam at 100 degrees, then I'd have one more step. But I stop right here. So I have 1, 2, 3 steps. You can see then that depending on what the problem is asking, you don't necessarily have to follow all 5 steps. You can have 2 steps, you can have 3 steps, etc., or 4. If you have other questions about these, then please send me an email and ask me a specific question. Say, this is the problem, this is how much I've done, and I'm stuck right here. So take a picture of the problem you're working on and say, I'm stuck here, will you please help me? That way I have an idea of how much you've done and where you're stuck. So, all right, this concludes the slides for Chapter 10.